Everybody, this is Caveman Math, and today I'll be talking about programming in Python and a few things that are very important when coding. So today I will be talking about mostly the importance of using relational operators, what they mean, nested conditions, using functions, using understanding global and local variables, as well as understanding what the prompts are asking you for. Like, for example, if you have a comp sci test, see if what they're asking for. So in the case of this prompt, so this prompt is asking for the user to write a Python function that will coordinate a point basically on an XY plane, right? So like, I'm sure you guys have used the graphs in math before or seen them. I've covered them in a lot of videos like logs and literally everything that has graphs and exponentials and just anything that uses a graph, slope, intercept. So you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant 1 has positive x values and positive y values. Quadrant 2 has negative x, positive y. Quadrant 3 has both negative, and quadrant 4 has positive and negative. So here it's asking us to basically write a function that can receive input, can use a correct data type, can use parameters, can use descriptive local and global variables, have nested conditions, use elif and else in it, as well as identifying the correct quadrant in which the points are. So like at the end you have to like print it out. But all right, so let's get to the meat and potatoes. Here I'm obviously using the turtle module to draw this out, because how else would you represent it if not by printing it? All right, let's get started. First, we import the turtle and we set up the global variable or function. So we see determine quadrant as listed on the prompt, and then we create our turtle, or we create our screen. So screen equals turtle.screen, and then this is our turtle at this point. So screen.title, and then the title is going to be, the title of the screen is going to be quadrant identifier, and then screen setup. This is where it's going to be set up at, exactly at this point on this graph that's going to be in the output box. So we create our turtle. So that was just screen. Now we create our turtle, which is t. So we change the t speed to 2, and then we take our pen up. So we're not tracing at this point. So our pen is up in the sky, right? And wait, let me stop this from running. So down here, we see how we need to draw the x and y axes, and pay attention how these are all in a local variable. All of these are under this def. So later on, we're going to call to this function, which is determine quadrant. All right, if we look down, we see t.pen down, because it went pen down when it went to that coordinate, go to -200 and 0, and then we placed our pen there, right? And then now it needs to draw it forward, so we're drawing the cross right now. So it's going to draw it, and then it's going to go pen up again, and then it's going to go to there, and then pen down, and then it's going to draw again, and then it's going to draw, and then it's going to pen up. But now it's going to change its location again to mark the point. So mark the input, basically. So it's going to go to x and y, which is whatever the user inputs, and then it's going to dot it by this size, I believe. And now it's going to write them out and align it with the screen. So it's going to write it out. It's going to say like x is this and y is that, and then now is where it's really important. So if x is 0, it's not equal to 0. If it is 0, and y is 0, t goes to 0 and -20, and then t writes the point is at the origin, or 0, 0. If not, so else, so just else, like all else, if this does not apply, all else, if x is greater than 0, then if y is greater than 0, go to here, like, or it's basically just pick a point to dot it on, because I feel like adjusting this and adding an accumulator for the amount of times it might go up or down and shift is going to be way too much to do on like a test. So I would say just pick a point on the screen at which that coordinate will stay depending on which quadrant it is. So for example, this is going to be quadrant 1, right? So if it's quadrant 1, then if y is greater than 0, then it's quadrant 1. If y is less than 0, so negatives, then it's going to be quadrant 4, because y's are negative in quadrant 4. And now it says if all else, so all else would be if all else fails, basically if all else does not work, then it will go to that point, and then it'll write positive x-axis, and then it'll just align it, and then say center. So now we have else if. So else if x is less than 0, and then under that global variable is actually not under global, but under that nested, it's nested as if y is greater than 0, then go to that point that we just allocate for printing out the answer. So t, right, and then the quadrant that it is in. So for example, it's quadrant 2. So if y is greater than 0, so if it's positive, then it's going to be in 2. And if x is less than 0. So we know that if x is negative and if y is positive, then it's going to be quadrant 2. All right, and just by confirming that, we know that if x is negative and y is positive, it is quadrant 2. So we know that. So we kind of just need to use that logic. So if x is positive and y is positive, then it's quadrant 1. If y is negative, then it's going to be in quadrant 4, because in quadrant 4, x is positive and y is negative. So following that logic, you can build yourself a structure that can determine whether or not a print statement should be written for the numbers that are inputted. So now, after we've written all of those conditions and set all of that up, we know that we can call it back and then turtle.done, which is keeping the window open until closed by the user. So now we just have to get the input because we already called it back. So we're already good. So actually, no, this is going to be calling it back. This is going to be calling it back. But now that we're done with that turtle, we can actually get input from the user. Me personally, I would actually move this up a little bit more. I would move this up, but I think that for now where it is how it should be. But now that I'm like looking back on it, I'm like, because you could write it really. Actually, no, because all of this is already said and done. But beginning is also better because now you know where your inputs are. So anyways, the input is written down here and it's stated as a float, which means that even decimals can be inputted. And then y coordinate, so determine quadrant, which is this definition up here. So def, so this is called here, right? And now it's called back here. So determine quadrant, and then x chord, and then y chord, and that's how it prints it out. So that's how that gets called back, and then all of this gets run. And if any of these go through, it's going to print these. So this is basically like a print for all of that if any of them happen. And then that's how it calls it back. All right, let's run this and see how it works. Let's enter the x coordinate. Let's say 5. Let's enter the y coordinate. Let's say 4. Oh, I need to restart this. Okay. So 5 and 4, there you go. I just plotted a point at 5 and 4. And for all you can know, this is like 5 and 4, but just on a really enlarged scale. But if you want to make this really, really accurate, you would have to kind of like set distances and increments for each one of them using like an accumulator, like a positive negative accumulator, and then setting conditions to determine how much it should be adding or moving, like should it be going up by 10s, by 20s, how far should it be going based on the number that was inputted. So that's a whole other ordeal and on its own. But yeah, that's pretty much it for making this quadrant and using turtles and using nested conditions like these if statements and elif statements and else statements, and also setting your variables, and also creating a turtle, setting a title for the screen, using your pen up to maneuver your turtle so it doesn't just draw everywhere, and then basically just using align. Also, align is pretty important because it just like aligns it with in this case center. So yeah, that's pretty much it for this prompt. I'm going to comment this out, and let's go on to the next one, which is okay, this one. So prompt 3. This prompt is by far the most important that you need to learn, because prompt 3, all right, let me scroll to the page where this shows very clearly how logic gates work. So here the example is shown, and it says write a Python program that will take the user's input for the values of A, B, and C and produce the correct output of this logic gate. But you already know your brother is going to figure a way out of this, yeah? So if you write down here, example, if the user inputs A true, B false, and C true, the output would print true. So now I need to create something that will replicate this output. So let me fix this up. I will be right back. Okay, hello Caveman brothers, I am back. I will now explain logic gates to you guys properly because I accidentally uncommented the wrong one. Now let me see if this code works. Enter a value for true or false. Let's say false. Let's say true. Let's say true. The output is false. Now let's run this again and let's do true, 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 because then that's an OR. True, 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 false. Wait up. False, false, false. Output is false. Okay, I can't really explain this to you guys, but because it's wrong, the code is wrong, it just outputs false. So what the question was asking was like write a code that will emulate a or and an and a not situation, so just a logic gate in general. So if I enter these values, so if I put a, and then it would be like if I put false or true. So I gotta fix this. This is not supposed to be like this. It's supposed to act like an OR gate or an AND gate. So if I make a combination, let me see if this works. So if I write if I write true, false, and true, it'll do false. That's not supposed to happen, because it's supposed to be true. True. Wait, nope. I'm gonna restart that. I'm gonna restart this loop. Okay, let's write in caps. True, false, true, true. Okay, that works. Okay, I can actually explain this because I had to input directly what I wanted to tell the computer. This is to the extent to which Python is exact. So here I set up my definition, I set up my function. This is my global variable, and then I have the local variables here, which are all set to true. So convert user inputs to Boolean. So these are all the user inputs. So A equals A upper, and then A equals B upper, and then C equals C upper, true, and then all of them is true. And then output equals to A and not B and C. So what that basically means is that, you know, it's an AND gate, because AND means that, okay, for example, if you're putting in an input, right, all of those inputs need, like, if one of them are wrong, then it's gonna be false. So like if you're going to put true, and one of them's not, actually no, wait, that's not, okay, if you're putting true, and one of them's not, then it's gonna be false. But like if you have like an OR, and then like even one of them is like gone, it's still going to be true. I believe that's how it works. So with that logic, let's go ahead. So we set our outputs to that, and then now we return this, right? Because these are our inputs. So now we actually set up the user inputs. So the Booleans were set up here, and now the user inputs. So user A is that, and then user B, and then user C. So now we use our result, and then that's the variable that we set up right now. And then logic gate output, which is this thing. It's our function that we're calling to. So now we're calling to that, right? And that's going to be A, B, and C, right? And now if that result, so print this, all else, print output is false. So if the result of this is true, then it's true. But if it's not, then it's false. That's why I was getting false, because everything else other than true, okay, so if I'm putting true, and I put one false, then it's true because of the AND relationship. Frankly, this is what the prompt is just telling. So it kind of just says, you know, A and B is and then it goes to not, and then it goes to or, which is the output. But then C is not or, so that's out. So that's why I put B not B, right? So A and not B, and then C. So because C is just not or, and then output. So that's how the output got returned. And then these are the user inputs. And if you pay attention, these are the ones that are stored inside the variable, inside the global. And these are the locals, right? And then it goes back to global because they're not indented. The indents kind of signify that. So I hope this helped in any way to kind of see how you're supposed to form your code so you don't bump into errors, because indentation is a very important part of this course, and I believe that all of you brothers can use this to the best of your advantage when taking these exams. Thank you so much for watching my videos. Caveman Math out.